Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing high weightage test 19 and that was based on differential equation, linear differential equations. I am discussing most incorrect questions done by the students. Okay, so starting with this question. In this question, we are given y equal to yx is the solution of differential equation x dy upon dx minus 2y equal to x cube ln x for x greater than 0 with initial condition. Then we have to find the value of y at e. Okay, so now to do this question, what we can do, we will first write this as a linear standard form, which is dy upon dx minus 2 into y upon x equal to x square into ln x. Now very standard form. Here you can see this is my p function. If you remember, the standard form of linear differential equation of one order is dy upon dx plus p into y is equal to q, where p and q are functions of x only. So here p is minus 2 upon x, so we will be finding integrating factor which is e raised to the power p dx. That p, if you compare it, is minus 2 upon x, so it will be e raised to the power minus 2 ln x. So this becomes 1 upon x square. Now the solution, as we know, solution is given by y into integrating factor, that is 1 upon x square, is equal to this right hand side q into integrating factor, so that will be just ln x dx. Okay, the integration of ln x dx is the formula you should remember, x into ln x minus x plus c. So this is the solution that we are getting, but we are also given the initial values, like at x is equal to 1, the value of y is minus 1. So if you put if I put x is equal to 1 here, value of y is minus 1, so this will be minus 1 upon 1 square is equal to 0 will be here, minus 1 plus c. So this gives you c equal to 0. This gives you c equal to 0. Now we have to find the value at x is equal to e. So I will put x is equal to e here. So y upon e square is equal to x into ln x at e. So it will be just e into 1 minus e, and the value of c was already 0. So this comes out to be 0 here. So y is equal to 0. So the final answer of this question should be D. Very simple question based on the standard form of linear differential equation. dy upon dx, py and q. P and q are functions of x only. Coming to this question, here we are given y equal to yx is a solution of differential equation dy upon dx equal to y upon x equal to xy square, where initial conditions are given and we have to find y of 2. So dear student, this is one standard form of linear, not linear actually, reducible to linear, and one special form in that is called Bernoulli's form. In that Bernoulli's form, what do we get? We get dy upon dx plus p into y is equal to q into y raised to the power n. So that is the Bernoulli's form, which we convert into linear differential equation by dividing by y power n. I'll show you how it is done, but you can compare. Your p here is 1 upon x, q here is x, and the value of n is y square. So very first step would be that we will divide by y power n. So we will divide by y square here. So we will be getting 1 upon y square into dy upon dx plus this will be 1 upon x into 1 upon y, and on the right hand side it will be just x. Okay, now we will be taking 1 upon y as z, 1 upon y as z or t, whatever you feel like. So 1 upon y is equal to z if we take. So the derivative will be minus 1 upon y square into dy upon dx, differentiating with respect to x will give you this thing. Okay, so now if I put all these things here, so this first thing will become minus of dz upon dx. here it will be plus z upon x equal to x. So to write this in the standard linear form, which is dy upon dx, is dy upon dx plus p into x, p into y, p into y is equal to q, or I can write p dash and q dash because already p and q are mentioned here. So p dash, q dash are functions of x only. So in this case, if I want to write this equation in this form, I just need to multiply by minus 1. So dz upon dx minus z upon x is equal to minus x. Okay, now integrating factor. Integrating factor is e raised to the power p dx. Actually p dash you can say, because this is my standard form. So which is minus 1 upon x. So it will be e raised to the power minus ln x, which becomes equal to 1 upon x. Okay, and then solution is given by z into integrating factor equal to this right side q dash into integrating factor, that will be just minus 1 dx, which is nothing but minus x and plus c. Now what was z? Z was 1 upon y. So this will become 1 upon y into x is equal to minus x plus c. Now we will find the value of c using this initial value which they have given. At x is equal to 1, y is 2. So if I put x is equal to 1 here, y will be 2 here. So we will be getting 1 upon 2 is equal to minus 1, x is equal to 1. So minus 1 plus c. So this gives you c is equal to 3 by 2. So this gives us c is equal to 3 by 2, and then we will be finding the value of function at 2. So we will be putting now this y, x is equal to 2. So 1 upon 2y is equal to minus 2 plus 3 by 2, which is equal to minus 1 upon 2. So this gives you finally answer of y as, I think y will go that side, and it will be equal to minus 1. So the final answer of this comes out to be minus 1 at x is equal to 2. At x is equal to 2, so answer would be B. So that is one method. Dear students, for this particular question, I can suggest you one more method. Please think over it. When we are given like this, we can multiply this x. We will be getting x dy plus y dx, and that will be equal to, I think, x square y square into dx. So what we have done, we have taken LCM x dx, so x dy here and y dx here, and this x dx of the numerator of the denominator going on the other side, multiplying with this will give you x square y square into dx. Now this we can combine together. And we get this as a d of xy. This kind of thing we do in exact differentials, where we combine two or more derivatives at one place. And on the right hand side we are getting xy dx, xy whole square actually, and we can now bring this xy in the denominator of this d of xy. So d of xy upon xy square is equal to dx. Now this integration can be done easily because my variable is xy. So this integration will be just minus 1 upon xy is equal to x plus c. I think this is same thing which we got here also in our first method. 1 upon xy equal to minus x plus c, and here also we are getting exactly same thing. C or minus c doesn't matter. So here also you can put initial value and then you can find the value of function at x is equal to 2. Okay. Coming to this question, here we are given fx is a differentiable function on 0, infinity with f1 is equal to 1, satisfying this condition that limit t tending to x, t into fx minus x into ft upon t square minus x square is equal to 1 upon x square. Now in this kind of question, first of all we need to notice that it is 0 upon 0 form. So as your t, which is variable, is tending towards x, this is becoming 0, this is also becoming 0. So we will be applying LH rule. We are given this function is differentiable, so we will be applying L'Hospital rule, LH rule, and we will be differentiating with respect to t. So with respect to t, if we differentiate, we will be getting limit t tending to x, differentiation of t will be 1, and we assume x as a constant. It is like t tending to some constant value, and here it is x. So t will be considered as a variable, x will be considered as a constant, minus x into f dash t whole divided by 2t. Okay, and that has to be 1 upon x square. Now we can put t equal to x because there is no 0 upon 0 form anymore now. So it will give you fx minus x into f dash x, okay, upon 2x is equal to 1 upon x square. Okay, so I can cancel one of the x in the denominator, and also what I will do, I will take y equal to fx. I will take y equal to fx so that I can write my equation in terms of dy upon dx, etc. So this will be y minus x into dy upon dx, and that will be equal to, I think, 2 upon x on this side. I think this is again a linear differential equation. If we simplify it, we will be getting dy upon dx, okay, and minus y upon x. Actually we are dividing by minus x on this side, so it becomes dy upon dx minus y upon x, and if we are dividing by minus x, so on the right hand side it will be minus 2 upon x square. Okay, now integrating factor. Now dear student, this is again the standard form. This is standard form of linear differential equation of one order dy upon dx plus p into x, p into y, actually not x, p into y is equal to q, where p and q are functions of x only. So you can see integrating factor will be e raised to the power p dx, and this p is minus 1 upon x, so e power minus ln x, and that after simplification is 1 upon x. So the solution would be y into integrating factor is equal to integration of minus 2 upon x square into 1 upon x, so minus 2 upon x cube dx. I think this becomes equal to 1 upon x square plus c. This becomes y upon x equal to 1 upon x square plus c. Now we are given initial value that at x is equal to 1, y is also equal to 1. So I will be putting 1 upon 1 is equal to 1 plus c. So we are getting c to be equal to 0. We are getting c to be equal to 0. Now after knowing c is 0, I think it is just a simple calculation to find the value at x is equal to 2. If I put x is equal to 2, we will be getting y upon 2 is equal to just 1 upon 2 square, that is 4. So y will be equal to 1 upon 2. So we are having one of the option as y equal to 1 upon 2. So answer of this will be B. Simple question. First apply LH rule to make it differential equation, and then solve this differential equation by the method which you should be able to solve it. In this case it is becoming linear differential equation. So use linear differential equation and get your answer. First you have to find c using initial value condition and then final answer. Okay, that's it. Dear student, I will like to tell you one more thing, that after knowing that linear differential equation, after knowing this differential equation which we obtained here, okay, so that was y minus, I would like to tell you method 2. In method 2 also we will be doing differentiation of numerator and denominator using LH rule, and then we will be getting this differential equation, that is y minus x into dy by dx, and that is, I think, equal to 2 upon x. Let me just check once again, 2 upon x. Now here what we can do, we can write this as y dx minus x dy, okay, is equal to 2 upon x into dx. Now here if I divide by x square, if I divide here also by x square, we will be getting this as a derivative of y upon x. You can check. First derivative of y into x minus derivative of x into y. So I think there will be minus sign here, and that will be equal to 2 dx upon x cube. 2 dx upon x cube. Now this method where we are combining two or more derivative is called exact differentials. So here we are getting minus d of y upon x is equal to this thing. Now if you integrate it, we will be getting minus y upon x on the left hand side. On the right hand side it will be minus 1 upon x square minus c, you can say. Now this is exactly same thing that we obtained using method of linear differential equation also. See, linear differential equation is also one direct method to create exact differentials. It's a systematic method, I will say. You are told how to get integrating factor, multiply it, will make your left side as an exact differential. But in this case, you have to think it yourself. So sometimes if these things are very standard one, like derivative of y upon x or derivative of x into y or some other things also, then it is suggested that you go with this method. It will save time. It will save maybe 1 minute of your solving time, and it will reduce the chances of error also. But again, if you're comfortable, only you do it. Otherwise, I think linear differential equation, that method 1 is better. Okay. Coming to this question, we are given y x be the solution of this differential equation with initial condition like this, and we have to find y of pi by 2. Now this again is, this here is directly in the form of linear differential equation. What is linear differential equation of 1 degree? 1 degree 1 order, dy upon dx plus p into y is equal to q, where p and q are functions of x only. In this case, you can compare p is minus 1 upon x. So integrating factor here would be e raised to the power integral p dx, which will be e raised to the power minus 1 upon x dx, which is equal to e power minus ln x. After simplification, it becomes 1 upon x. So the solution would be that you multiply y with 1 upon x is equal to, I think, just integration of sine x, because x will cancel. Okay, this becomes minus cos x plus c. Okay, now at pi, if you put x is equal to pi, the value of y is 2 pi. So 2 pi for y upon pi, that is 2 on the left hand side, will be minus minus plus 1, because at pi cos pi is 1 minus 1, so minus minus plus 1 plus c, and this gives you c is equal to 1. Now we know value of c. Now we can find the value of function at pi by 2. Just put x is equal to pi by 2 here. So y upon pi by 2 in place of x is equal to minus cos x will become 0, and this c is 1. So the value of y is coming out to be pi by 2. So this should be the answer of this question. So what is the answer? Let me see. Yeah, A. A should be the answer of this question. That is, yeah, A. Here also, although it is directly based on linear differential equation, so nothing is to be done. But dear student, one more method you can think of, although in this question it is not recommended. You can write this as x dy minus y dx is equal to x square sin x dx. If I divide by x square here, if I divide by x square here, this will become d of y upon x, and that is sin x dx. This method is called method of exact differentials. Okay, so you can integrate it. So it will be y upon x is equal to minus cos x plus c. Now after this, it is exactly same what I did in my method 1. This y upon x is equal to minus cos x plus c. So here this is not standard approach. Standard approach is that only where if we know it is coming in our standard linear differential equation, just find integrating factor and then solve it. But in this case, you just by observation try to club certain differential terms to combine into one and then integrate it. So that's the idea. But again, this method should be applied when you are very comfortable with these kind of expressions. Otherwise, the earlier one was the better one. Now in this question, we are given y equal to yx be the solution of differential equation dy upon dx is equal to x plus y whole square minus x plus y minus 1 with initial condition. Then we have to find the value of x plus y at x equal to ln 3. Now dear student, if I bring 1 here, so it will be 1 plus dy upon dx is equal to x plus y whole square minus x plus y. Now we can combine this as derivative of y plus x upon dx, which will be just dy upon dx plus 1, and this is equal to x plus y whole square minus x plus y. Now obviously, now I will be putting x plus y as some z or t. Let us take t this time. So x plus y is equal to t. So this will become dt upon dx, and this t I can bring it here and is equal to t square. Okay. Now dear student, I can do this question in two ways after this. This can be thought of as a variable separable, actually not linear but variable separable here. Also this can be linear differential equation, but actually reducible to linear differential equation where it is Bernoulli form. What is Bernoulli form? If we are given this kind of differential equation, dy upon dx plus p into y is equal to q into y power n. We divide by y power n on both sides and we get it into linear differential equation, and then we do by method of linear differential equations. Here you can check your p is 1, q is also 1. Okay, see here in place of y it is t, okay, and in place of n it is 2. So if we use that Bernoulli's form, I will be dividing by t square, so it will become 1 upon t square into dt upon dx plus 1 upon t is equal to 1. Now in such case what we do, we put 1 upon t as another variable, let's say u. So this minus 1 upon t square into dt upon dx will be equal to du upon dx. Okay. Now if we put these two things in this differential equation, so we will be getting minus du upon dx plus u is equal to 1. Okay, so I will write this as du upon dx minus u is equal to minus 1. Now this is linear differential equation. What is linear differential equation? Of first degree, first order, dy upon dx plus p into y is equal to q. Already p and q are used here in the screen, so I will write p dash q dash. Now p dash q dash means p dash q dash are the functions of x alone. Here p dash is minus 1 and q dash is minus 1. So to solve this question now, what I will do, I will find integrating factor. So integrating factor will be equal to e power p dash x, that will be equal to e power minus x. You can check this minus 1 is your p dash, so integrating factor will be e power minus x, and then solution will be u into e power minus x is equal to integration minus 1 multiplied with e power minus x dx. So that is equal to e power minus x plus c. Okay, now we have done 2 times substitution. U was actually what was u? 1 upon t, and t was x plus y. So basically u is 1 upon x plus y. U is 1 upon x plus y, and this I can write it as, if I multiply by e power x, so 1 plus c into e power x. So this is what we are getting our solution. Now we are given initial conditions at x is equal to 0, y is half. So if I put x is equal to 0, y will be half, and that will be 1 plus c into, I think 1. X is 0, so this will be 1. So this becomes 2. So this will give you the value of c as 1. So value of c is 1. Now we have to find the value of this function at x is equal to ln 3. So put x as ln 3. So 1 upon ln 3 plus y will be equal to 1 plus c is also 1. And if you put x is equal to ln 3 in the power of e, I think it will be just 3. E raised to the power ln 3 is 3. So this becomes equal to 4. So we are getting y plus ln 3 is equal to 1 upon 4. Okay. So, and they are asking the value of actually x plus y. Okay. So x plus y means y plus x. So I think this will be 1 upon 4 only. This was x and this is y. So the value of x plus y at x equal to ln 3 is, I think C should be the answer of this question. Yeah. Okay. Yep. So that was one method. But dear student, as I was telling you, there can be one more method, that is variable separable. So after taking one this side, we will be getting d of x plus y upon dx is equal to x plus y whole square minus x plus y. And if you take x plus y as t, this becomes dt upon dx is equal to t square minus t. So it is a variable separable. You can bring t square minus t on the left hand side and you can write this as dt upon t into t minus 1 is equal to dx. Okay, and then this can be integrated after breaking into partial fractions. It will be 1 upon t minus 1 minus 1 upon t dt, this 1 upon t into t minus 1, yeah, and this is equal to dx, not dt, this is dx. So after integration it will become ln of t minus 1 upon t is equal to x. And what was t? T was x plus y. So I think we are done. This is equal to this plus c, and I think after that the question is very much simple, similar to what we have done before. So it will be x plus y minus 1 upon x plus y is equal to e power x into e power c. Okay, using the initial value y is equal to 0, okay, it will be 1 upon 2. One more thing here, there is one important thing whenever you are taking log, because we are getting mod here, and if you notice here at x is equal to 0, y is 1 upon 2. So this will become negative here. X plus y will still be positive, but this will be negative, and we need not to remove mod till this stage, and then we have to think over that this will actually become 1 minus x plus y upon x plus y, because my mod has to be open such that the final expression is positive. So that will be e power x into e power c. Now you just put x is equal to 0, y is equal to half, and then get the value of c, and then put x is equal to ln 3, you will get the final answer. So this is the second method. After solving it is same thing, but the difference only was of that whether you do it by Bernoulli's, then linear, or by variable separable. I think variable separable is more better method because it is done in just one step. Otherwise in Bernoulli's form and then linear, there are 2 steps involved. Okay, so answer was, yes, C only, I corrected it. Coming to this question, it says the solution of dy upon dx plus y into cot x equal to 2 cos x. Okay, x is between 0 to pi, satisfying some initial condition, and then we have to find y at pi by 6. So this is directly linear differential equation dy upon dx plus y into p is equal to q, where p and q should be functions of x only. So in this case p is cot x and q is 2 cos x. So the first thing that we should find out is integrating factor, that will be e raised to the power p dx. So this becomes e raised to the power, and p is cot x, and the integration of cot x is ln of sin x. So this becomes just sin x here. Okay. Now after knowing integrating factor, we will be integrating after multiplying sin x, that means integrating factor with y. So the solution will be y into sin x is equal to integration 2 cos x sin x dx. We can do this integration 2 ways. One, we can write this as sin 2x, or you can think of sin x as t, cos x dx as dt. Then this integration will be directly sin square x also. This integration will be sin square x also, you can think over it, or sin 2x, then this integration will be minus cos 2x by 2. Both ways you are getting same thing, the only difference will be of your arbitrary constant c. So I will go with this. Now they are saying when x is equal to pi by 2, when x is equal to pi by 2, so this y is 1, so 1 into 1, because sin pi by 2 is 1, is equal to 1 plus c. So this gives you c is equal to 0. So now c is equal to 0, I think question is very simple. We are getting just y is equal to sin x. That is the solution of this differential equation, and they are asking the value at pi by 6. X is equal to pi by 6, so this will be 1 upon 2. So that should be the final answer of this question, that is B. Okay, I think this is the only method of this question because it is a linear differential equation. You cannot do anything else other than trying to convert this into exact differential. That can be done, but I think this is very systematic, and you must know this form linear differential equation, so go with this method. Okay. Coming to this question, y equal to yx be the solution of differential equation for x belongs to -1, 1 and y0 is 1, then we have to find this limit, okay, x tending to 1 minus yx. Okay, so how to do this question? Let's see. First of all, I will convert this as a linear differential equation if I divide by dy upon dx, if I divide by root 1 minus x square. So that will be plus y upon root 1 minus x square is equal to e raised to the power cos inverse x upon root over 1 minus x square. Now this is your linear differential equation of first order, first degree, which is one standard form like this. P has to be, Q has to be functions of x alone. So here also you can see it, that P is 1 upon root 1 minus x square. So the next step is we find the integrating factor, which is e raised to the power p dx. So integration of 1 upon root over 1 minus x square dx. So this becomes e raised to the power sine inverse x. So we will multiply e power sine inverse x with y. So our solution will be y into e power sine inverse x. Okay, and on the right hand side it will be multiplied with this. So e power sine inverse x plus cos inverse x divided by root over 1 minus x square dx. Okay, now sine inverse x plus cos inverse x is pi by 2, very standard identity. So we can bring e power pi by 2 outside also, and integration of 1 upon root 1 minus x square is sine inverse x plus c. Okay, so this is what we are getting. Now initial value at x is equal to 0, y is 1. So if I put x is equal to 0, y will be 1, and e power 0 it will become, on the right hand side it will be e power pi by 2 into 0 plus c. So the value of c is coming out to be 1. Okay, so in this we can now put c is equal to 1, and then we have to find x tending to 1 minus. Dear student, if I write y in terms of x, let me write it completely. So it will be y equal to, I think, e raised to the power pi by 2 minus sine inverse x. We can also write this as e power cos inverse x into sine inverse x plus c was 1. So 1 into e power minus sine inverse x. So this is the solution that we are getting. Now this function seems to be continuous at x is equal to 1. So whatever the value of this function will be at x is equal to 1, same will be the limit at x tending to 1 minus. They are talking only about left hand limit because sine inverse x is not defined for x greater than 1. So only left hand limit is found. So we will be putting x is equal to 1 here. Let me do it here itself. I think I am having small space here. So if x is equal to 1, sine inverse x will be pi by 2. So pi by 2 minus pi by 2 is 0. So this will become e power 0, and sine inverse 1 will be pi by 2. And here it will be plus e power minus pi by 2. So we get pi by 2 into 1, e power 0 is 1. So final answer will be, let me write it here. So the final answer will be y equal to pi by 2 plus e power minus pi by 2. So this is how this question is solved, and answer will be A of this question. Okay. Actually I am thinking of any other method, but I feel this was a good method for solving this question because you are directly getting this into linear differential equation and then nothing like this. Okay. Okay. So that's it, bacho. I think that was the last question. Thank you so much. Thank you all of you. Take care, bacho.